Right, section 3.6 is on factoring trinomials of the form ax squared plus bx plus c. So basically, we're talking about trinomials that have a coefficient in front of the x squared term that is different than 1. So something that would probably not be able to be factored out as a GCF from the trinomial. So to start off, learning how to factor those, we can investigate a little bit. So if we look at expanding again two binomial factors, multiplying them out, we would have, for example, the first one here, 3x times 2x is 6x squared. And then the 3x times the 3 is 9x. And then we move to the 1 times the 2x is going to be 2x. And then 1 times the 3 will be 3. So if we combine that, we get 6x squared plus 11x plus 3. So the pattern that you're looking for kind of involves those middle terms there, the numbers, the coefficients of those middle terms. And if you look at the coefficients of the 9x and 2x terms, you can see that 9 and 2 add to give you 11, and they have a product of 3 times 6. So let's see if that follows through in the second product now, that we multiply out these two binomials in part B. So 5t times t would be 5t squared. And then 5t times the negative 7 is negative 35t. And then the negative 2 times t would be minus 2t. And then the negative 2 times the negative 7 would be positive 14. So if you put the like terms together, you get 5t squared minus 37t plus 14. And this one's a little bit harder to see, I guess, because the numbers are a little bit larger. But negative 35 and negative 2 will add to give you negative 37. And if you multiply negative 35 and negative 2, you do get 70. And if you look at the product of 14 and 5, that is also 70. So there is a very similar relationship to what we did in factoring x squared plus bx plus c types. It's just that this time the product, it has to be two numbers, the two numbers that we're looking for, to get to these two numbers here, these middle terms here. These two coefficients that we're looking for have to multiply to give you the product of the leading coefficient and the constant term, and they have to add to give you the middle term in your trinomial that you're starting with. So if we go back and apply that and see if we can use that to factor, we basically would be looking for two numbers which have, if we're looking to factor ax squared plus bx plus c, we would be looking for two numbers that have a sum of what the b term is and have a product of what a, the leading coefficient, and c, the constant term are. And if I just go back and look at the last example just before this summary there, we look at the example of 2x squared minus 7x minus 15, two numbers that multiply to give you negative 7 and add to give you negative 30 are negative 10 and 3. So if you rewrite that middle term negative 7x using those two numbers, you can kind of work backwards and get your factors. So let's put some of that into practice now. Okay, so we're going to use the method to try to factor 2x squared plus 15x plus 7. And this method is called the decomposition method because it basically breaks down the middle term into parts. And when you think of the word decomposition, in biology or science, you usually think of breaking down. So that should help you to remember what you have to do when you're factoring using this method. So decomposition is basically breaking down the middle term. So the first thing we do with 2x squared plus 15x plus 7, just check first to make sure there's no GCF that can be factored out, and there isn't. So then you would have to look for two numbers which have a sum of the b value, which in this case would be 15, and a product of the A and the C value, which would be 2 times 7. So when we go over and fill them into the spaces over here, we need a product of 14, 2 times 7, and we need a sum of 15. So if you think of the factors of 14 that multiply to give you 14 and add to give you 15, that would be 1 and 14. So then we would take those two values and break down the middle term of our trinomial. So we have 2x squared plus 15x plus 7. And then we're going to break down that b value using the two numbers we just came up with. So that would be 2x squared plus 1x plus 14x. And it doesn't matter if you put the 14x first or the 1x first, doesn't matter. You'll eventually end up with the same two factors. So we've just basically rewritten the trinomial. It still means the same thing because 1x plus 14x do combine to give you 15x. So then the next step is to group. So break it down and then group and take out the GCF of each group. So we're going to group by underlining. We're just going to underline the two groups. And then we're going to factor the GCF of it. I'm just going to move down to it's next to this step. So we're going to take the first group of 2x squared plus x, and the GCF of 2x squared plus x is just x. So when we take that GCF out of both those terms, we end up with a 2x plus 1 left inside. And then we move to the next group, and the next group is the 14x plus 7. And out of those two terms, 7 is a GCF, and when we look at what's left inside, 14x divide out the 7, you get 2x, and 7 divided by 7, you get 1. So when you look at what you have there now, you've got two groups added together, the x outside of the 2x plus 1 plus the 7 outside of the 2x plus 1, and if you concentrate on this binomial factor, that is a GCF of each of those groups. So we could pull that out as a GCF, 2x plus 1. And if we divide it out of the first group, we have x. And if we divide the 2x plus 1 out of the second group, we're left with 7. And then these, 2x plus 1 and x plus 7, would be your factors of your original trinomial. So if you want, you can check to make sure that you've got the right factors by just using the distributive property, or FOIL in this case, because they're two binomials. So 2x plus 1 by x plus 7, and if you expand that, you will get 2x squared plus 2x times 7 is 14x, plus 1 times x is 1x, or just x, and plus 1 times 7 is 7. And that will combine to give you 2x squared plus 15x plus 7. So you're done. It is correct. Okay, we're going to try a few examples now of factoring using the method of decomposition. So the first one here is 2x squared plus 7x plus 3. So if we kind of summarize our steps, we need to find the numbers first. That's our first step, which is, in this case, two numbers that multiply to give you 2 times 3, which is 6. And they have to add to give you the coefficient of the x term, which is 7. So if you think about the factors of 6, 1 and 6, 2 and 3, the two factors of 6 that multiply to give you 6 and add to give you 7 would be 1 and 6. And they would both have to be positive because you have a positive product and a positive sum. So then the next step, find the numbers, was the first step. Then the next step is to break it down. So you take the middle term and you rewrite it using the numbers that you found in step 1, which would be 1x plus 6x, and you still have a plus 3. So it doesn't matter if you put the 1x first or the 6x first, you'll still get the same answer in the end. You'll get the same two factors. They might be written in a different order, but they would be the same two factors. So find the numbers, break it down. Next step, we'll summarize to GCF group in GCF. So you group the first two, you group the next two, and then you take the GCF out of each group. So the first one would have a GCF of x, and then you take that out of 2x squared, you'd be left with 2x, and the x out of 1x would be left with a 1. In the second group, 6x plus 3, 3 goes into both of those, so you'd have a 3, and 6x divided out the 3 would be 2x, 3 divided out the 3 would be 1. And then the last step would be to your final factors that you have to come up with. Again, you would be taking a GCF out, but it would be the binomial this time. And so the GCF of your two groups that you have here are 2x plus 1, is 2x plus 1. That's your GCF. And you'd have x, when you take it out of the first group, you have x left. You take it out of the second group, you have a 3 left. So those would be your factors. And you can check if you want. We'll just do a quick check in our heads. 2x times x gives you 2x squared. 2x times 3 gives you 6x, plus 1x plus 3 will give you the polynomial that you started with, the trinomial. All right, so I'm not going to write out the steps again, so you got them there. But the next one, you're looking for two numbers which multiply to give you negative 12, and add to give you positive 1. And if you think about the factors of 12, you've got 1 and 12, 2 and 6, 3 and 4. And 3 and 4, if one of those is a negative, they will multiply to give you negative 12. And if you want to have a positive one when you add them, you'd need the negative to be with the smaller of those two numbers. So negative 3 and 4 would multiply to give you negative 12 and would add to give you positive 1. So those are the numbers. So you found the numbers. Now you have to, I'm just going to rewrite it down here so I got a little bit more space. That's so squished. So 4x squared plus x minus 3. So we found the numbers. Now we're going to break down the trinomial with those two numbers. So we got 4x squared minus 3x plus 4x. And then we still got the minus 3. So all we've done is we've rewritten the middle term. So find the numbers, break it down, group in GCF is the next step. So then we're going to group the first two, group the last two. And if you look at the first two, there's a GCF of x. And when you take that out of those two terms, you'll have 4x minus 3 left. In the second group, there's nothing in common. So when there's nothing in common, you take out a 1. And then you've got 4x minus 3. And now if you look at this group and this group, you can see that they both have a common factor of 4x minus 3. So you're going to take that out side. And then what you have left, if you take 4x minus 3 out of the first group, you're left with x. And if you take it out of the second group, you're left with 1. And this would be your answer. I should highlight the last one as well. This was our answer. Okay? And if you just do a quick check in your head to see if that does multiply out to give you what you started with, 4x times x will give you 4x squared, plus 4x minus 3x will give you positive x, and then minus 3 times 1 will give you the negative 3. So they are the correct factors. All right, so if we check the next one now, we're looking for two numbers that multiply to give you 3 times a negative 6, which is negative 18. And they have to add to give you a negative 17. So if you think about the factors of 18, again, one would have to be positive and one would have to be negative in order to have a product that's negative. So the factors of 18, 1 and 18, that would work because if you had positive 1 and a negative 18, you would get a negative 18 for the product and a negative 17 for the sum. So then I'm just going to rewrite it again down here. 3x squared minus 17x minus 6. So we're going to rewrite the middle term using those two numbers. So 3x squared plus 1x minus 18x minus 6. So all we've done is rewritten that middle term using the two numbers we found in the first step there. So 1 and negative 18. 1x and negative 18x are exactly the same thing as negative 17x. So now we group, so find the numbers, break it down, group and GCF. So now we've got the GCF of the first group would be x outside of 3x plus 1. And the GCF of these two, 18 and 6. Well, they take out, and if the second group has a negative in the first term, even if it's not in both, you should always take that negative out. So this would be negative 6 outside of, kind of squished there for space, 3x plus 1. Can't get my bracket in there. See if I can erase that and write it out a little bit better so that you can see it. So this would be, x outside of 3x plus 1, and then minus 6 outside of 18 divided by, negative 18 divided by negative 6 is 3, and the x, and negative 6 divided by negative 6 is positive 1. When you take out a negative outside, everything inside will be the opposite sign of what it was in the step previous. So now we look at these two, and we know that 3x plus 1 is in both of them. So 3x plus 1 outside of x minus 6 would be our factors. And if you check, 3x times x is 3x squared minus 18x, and then the 1 times the x would be positive 1x, so then minus 18 and positive 1 will give you negative 17x, and then the last terms 1 times the negative 6 will give you negative 6, so you will get that back again. All right, here's some more for you to try, but I'll do them with you. So the first one, you are looking for two numbers which multiply to give you 2 times 5, which is 10, and they have to add to give you 11. And that would be 1 and 10. Multiply to give you 10 and add to give you 11. So then you're going to break down the middle term, 2m squared plus 1m plus 10m is the same thing as 11m, and then you still get your plus 5. So find the numbers, break it down, group, and GCF. So first group has a GCF of m outside of 2m plus 1. And the second group has a GCF of 5 outside of 2m plus 1. And then you've got 2m plus 1 is your common binomial that's in both of those groups. And when you take it out of the first group, you're left with m. You take it out of the second group, you're left with 5. And these would be the factors. This would be your answer. Okay, so the next one, we're going to be looking for two numbers which multiply to give you 3 times a negative 10, which is negative 30, and add to give you what's in front of the m there, which is negative 1. So they add to give you a negative 1. So if you think of the factors of 30, again, one of them would have to be a negative and one would be a positive, so that their product is negative. So if you think of the factors of 30, 1 and 30 is not going to work. 2 and 15 will multiply to give you 30, but if one of those is a negative, you won't get a sum of negative 1. 3 and 10 is not going to work. 5 and 6 will work, though, if the 5 is the positive and the 6 is the negative, because they will multiply to give you negative 30 and will add to give you a negative 1. So then we break down the middle term, so it'll be 3m squared plus 5m minus 6m, and then minus 10. So my arrows should be kind of pointing here and here. You're breaking down negative m as 5m minus 6m, which is exactly the same thing. So find the numbers, group, and GCF. So the first group, there's only an m in common outside of 3m plus 5. And in the second group, take that negative out. If the first term of your second group has a negative, regardless of whether it's in both terms or not, always take it out. So then you've got a negative there, and 6 and 10 would have a 2 in common. So that would give you 3m plus 5, because you've already taken the negative out. And again, you've got the same thing left inside the brackets there, so you pull that out as a GCF, and you get 3m plus 5. If you take it out of the first group, you're left with m, and if you take it out of the second group, you're left with minus 2. So there are your factors for your trinomial. Okay, the next method we're going to learn is the box method, and this is another method that you can use to factor trinomials. It is important, though, when you're using this method that you always check and factor out any GCF that's in the trinomial first. So just write that little note there, factor out any GCF first. Okay, so the trinomial that you're working with should not have a GCF for the 3 terms that are in your trinomial. All right, so the first one there, you've got 2x squared plus 15x plus 7, and that's the same one we did using the decomposition example a few pages back. So we're going to do this one now using the box method. And we check first and 2x squared, 15x, and 7. There is no GCF between those 3 terms, so we should be able to use the box method to do that. And we're still looking for, we started off the same way we start off with the decomposition method. We're still looking for 2 numbers which have a sum of the b value, which is 15, and a product of the a and the c value, which is 2 times 7. So we want a product of 14 and a sum of 15. So again, those 2 numbers would be 1 and 14. And then what we do is we draw the box with the 4 sections, just like this already drawn there for you. And then the next step is to take the terms of your trinomial and put them in the sections of the box. But you would have to, I've got to remember what it is now, 2x squared plus 15x plus 7. So you would have to, just going to write it here again. So you've got 2x squared plus 15x plus 7 is the trinomial. So what you're going to do is you're going to put the 2x squared here. You're going to put the 7 down here. But instead, and then you're going to take the 2 numbers that you just came up with, the 14 and the 1, and you're going to put those in the other 2 boxes. So so now we've got 2x squared here. And you don't have to draw these boxes over and over again. We're just doing it step by step to show you in this case. So you've got 2x squared here, you've got 7 here, and then you can put the 14x in this box and the 1x in this box. So it doesn't matter where you put the 14 and where you put the 1. You can put the 1 up here and the 14 down there. It doesn't matter. All right. So then what you would do is when you have that done, so just to write that out again there now, and again, you wouldn't be writing this out all these times. You'd only have the box written down once. So then what you do is you look at each row and each column and you factor out the GCF of each row and each column. It is important, there's a little note there on the side, it is important that if you have a negative at the beginning of a row or column, that comes out even if it's not, even if both terms aren't negative. All right, so the first one here, if we look at the row here, if you look at the 2x squared and the 14x in the first row, they have a common GCF of 2x. If you look at the second row, x and 7, there's only a GCF of 1 there. If you look at the first column, the 2x squared and the 1x, if you look at that column, the only thing that's common there is an x. And if you look at the 14x and the 7, the only thing, that second column there, the only thing that's common there is a 7, positive 7. So when you put that together, that's a 2x and a positive 1, an x and a plus 7. That would mean that your factors are, I'm just going to squeeze them down here, 2x plus 1 and x plus 7. And again, you can multiply that out to check. 2x times x is 2x squared plus the 14x plus the 1x gives you 15x, and then 1 times 7 gives you the positive 7. So you know you got the right factors. All right, so we're going to use the box method to factor each of these trinomials. And first we'll just double check, make sure that there's no GCF for 2m squared, 11m, and 5, and there isn't. So now we can come up with 2 numbers that multiply to give you 2 times 5, which is 10, and add to give you 11, which is 10 and 1. So that means in this corner we write the 2m squared, and in this corner we write the 5. And then we write 10m in one of the other remaining corners and 1m in the other one. And then we start factoring out the GCF from each row and column. So in this row here, we've got a 2 and an m as a GCF. In the second row, we've just got a 1. In the first column, we've got 2m squared and an m. The only thing that's common there is an m. And in the second column, we've got a 10m and a 5, so the only thing that's common to both of those is a 5. So that means our factors are 2m plus 1 times m plus 5 is the other dimension. And again, if you do a quick check, 2m times m is 2m squared, 2m times 5 is 10m, 1 times m is 1m, so that will add to give you 11m, and then 1 times 5 is 5, so we know we did it right. In the next example, we check again to make sure there's no GCF before we start, and we are looking for two numbers that multiply to give you 3 times a negative 10, which is negative 30, and they have to add to give you a negative 1. So that would be negative 6 and 5. So we want to put in our terms here. So we have a 3m squared, and we have a negative 10, and we have a negative 6m, and we have a 5m. So if we factor out the GCF from each row and column, the first one we've got a 3 and an m. In the second row we've got a 5 that's common. In the first column here, 3m squared and 5m, there's only an m that's common. And in the second one we have a negative 2. Negative 2 would be the only thing common to 6m and 10. And the negative, of course. So the factors would be 3m plus 5 by m minus 2. And again, we can quickly check in our heads. 3m times m would give you the 3m squared. 3m times the negative 2 would give you negative 6m. 5 times the m would give you 5m. And 5 times the negative 2 would give you negative 10. So that would work. The last method is the guess and check method, which is the way that I was taught. Those other methods weren't taught when I was in school, but the guess and check method is more just using the idea of kind of reversing the FOIL process and knowing that when you have a trinomial, this first term will always come from the product of the first terms in your binomial factors, if it is factorable. And the second terms in the binomial factors will always multiply to give you this last term. And then, so you check basically combinations that will fit the first and last term, and then as you're doing that, you kind of quickly check the product of the inside and outside products, because when you FOIL, or when you use the distributive property, you got your 2x times your x will give you the first term, and your 3 times the negative 4 will give you the negative 12. But the inside and the outside have to combine to give you the 5x here, the negative 5x. So this inside product and this outside product have to combine to give you the negative 5. So if you quickly check, when you do the inside product, you get positive 3x, and when you do the outside product, you get a negative 8x. So they will combine to give you a negative 5x. So those would be the factors. So we'll just do a couple of these. Guess and check is always a good method to kind of have if you kind of forget the other ones. I've used guess and check all the time because I find it quicker, and it's the way that I learn. But for those of you who like process, step-by-step process, probably the decomposition would be the best one to go with. Or if you use the box method, just make sure that you take the GCF out first, if there is a GCF for all three terms before you start. All right, so let's take a look at the guess and check method here. So the first one here, we have basically 2x squared is our first term. So if this has binomial factors, the only two things that will multiply to give you 2x squared will be 2x and x. And then you look at the negative 3. So you need two numbers that multiply to give you a negative 3. So if you put in, for example, a 1 here and a 3 here, and put the negative here and the positive here, that will multiply to give you a negative 3. You will get 2x squared for the first term, and you will get the last terms will multiply to give you negative 3. But if you check the inside product, you get negative x, and then the outside product, you get positive 6x. So when you add those, you actually get a positive 5x, not a negative 5x. So we're on the right track, and we can fix that if we have the negative with the 6x and the positive with the 1x. So we'll go back and change that to a positive 1, and this to a minus 3, and then we'll have positive x and negative 6x. And the first terms will be 2x squared. The last terms do multiply to give you still negative 3, and then the inside and outside do give you the negative 5x. So these would be the factors. X squared, I'm just going to, I guess it won't take away the blue, hey? It won't take away the black, I mean. So this here would be minus. And this here would be a plus. Okay, if I had a little bit more space, I'd write that out again, but I'm limited here in my space. All right, so let's try the next one now. So the factors for the last one will be 2x plus 1 by x minus 3. So the next one here, if we are to try to factor that using the guess and check method, we'd say, okay, if it is factorable, there would be two binomial factors, and 3x squared. The only combination that would give you 3x squared is 3x and x, so we can put that in. Now 8, we've got a couple of combinations for 8. We can have 1 and 8 or 2 and 4. And if we just try 1 and 8, and again, they would both have to be positive because they're going to add, multiply to give you a positive 8, and when you add the two terms, it's still a positive. So they would both be pluses here. But when I check quickly, I will get the first terms will give me 3x squared, the last terms will give me 8, but the inside and outside are going to give me 1x and 24x, which is way too much. And even if I switch the 8 here and the 1 to here, because now the 1 only gets multiplied by 3 and the 8 only gets multiplied by the x there, we get 8x and 3x, which is still too much. Not enough, sorry, you need 14x, is not the right combination. So we're going to go back and we're going to try again, because 1 and 8 doesn't seem to work. So then we would try 2 and 4. And if we just look for a minute, we need to get 14. So if I put the 4 here, that's going to get multiplied by the 3x, which would give me 12x. And then if I put the 2 here, that would give me 2x. And 2x and 12x will give me the 14 that I need. And I will still have the 3x times the x. The first terms will give me 3x squared, and the last terms will give me the positive 8, and then the inside and outside do give me 14. So my factors would be 3x plus 2 and x plus 4. And the last one, so you can see guess and check can be tricky if you've got a lot of combinations to check for either your first or your last term. It can be especially tricky if you got more than one combination for the first terms and more than one combination for the last terms of your binomial factors. But the ones we're doing here are nice ones, they're not too bad. So 2x squared would be 2x and x is the only combination you can have to break up the 2x squared. And then you look at 18. Now we've got a few more possible combinations for 18, and it's a negative 18, which means one has to be plus and one has to be minus. So if we think about the factors of 18, 1 and 18, and again, if I put the 1 here and the 18 here, I'm going to get 1x and 36x, and one of them would have to be a negative. So I'm just going to put the plus here and the minus here for now. That would be a negative 36x and a positive 1x, which is not going to combine to give you 9. And even if I put the 18 here and the 1 here, it's still going to give me 18x and negative 2x, which is 16x. And even if I switch the negative around, it would give me a negative 18x plus 2x is still positive or negative 16. So that's not going to work. So then I can check, the next factors I can check for 18 would be 2 and 9. I'm just going to erase this. So if I check 2 and 9, 2, if I put the 2 here and the 9 here, that's going to give me 9x and negative 4x, which isn't going to work. And even if I put the 9 here and the 2 here, that's going to give me negative 18 and 2, which is still not going to work. So then I can check, and again, even if I switch the positive where the negative was, it's still going to give me, not going to give me 9, it's going to give me 16x. All right, so if I check the next one, I can check, that's factors of 18, would be 3 and 6. So if I put the 3 here and the 6 here, I will get negative 12x and a positive 3x, which is almost what I want. It's negative 9x instead of positive 9x. So then I could switch this to my negative and this to my positive. And then I would get the negative 3x and I would get the positive 12x, which would combine to give me positive 9x. And I would still have 2x times x for my first terms to give me 2x squared, negative 3 times 6 to give me my negative 18 for the last term. So that would be your correct factors, 2x minus 3 and x plus 6. All right, so this is an extra practice worksheet now on some of the topics we've learned in this section. So the first one is just expanding or multiplying it out. So if you can use your rectangle model or whatever you want, but I'm going to use the distributive property. And you don't have to draw these arrows in, I'm just reminding you how to do it. So 5x times 2x is 10x squared. And then the 5x times the 4 is going to be 20x. And then 3x times 2x is going to be 6x. And then 3 times the 4 is going to be 12. So we have 10x squared. And put your like terms together, it would be 26x. Plus your 12. And the next one, another 2 binomials to multiply. We've got 6t times 7, that's going to give you 42t. And then 6t times negative 5t is going to give you negative 30t squared. And then you got minus 9 times 7 is minus 63. And minus 9 times negative 5t is positive 45t. So then we're just going to put that in order and put like terms together. So we've got a negative 30 t squared. And we've got 42t and 45t, so that would be plus 87t minus your 63. All right, so the factoring, I'm going to use the decomposition method because I prefer the algebraic ways of doing things. So if you want to use it, the guess and check or the box method, you can use that. And most of these here, I'm just going to kind of stick to the decomposition so that you guys can see the pattern. That's probably a good one for you to try. If I had more time, I would probably drill in the guess and check one because I think that's a nice quick one to do. But we'll stick to the decomposition for now. All right, so 4g squared plus 11g plus 6, you're looking for two numbers which multiply to give you 24 and add to give you 11. So that would be, think of the factors of 24, 3 and 8 would multiply to give you 24 and add to give you 11. So you break down the middle term, 4g squared plus 3g plus 8g plus 6, and then you group and GCF. So take the GCF of the first group would just be a g outside of 4g plus 3. And the second group, the only thing that's common between those two terms would be a 2. And you'd be left with 4g again, plus 6 divided by 2 is 3. So then you've got 4g plus 3 outside of g plus 2. In the next example, we're looking for two numbers that multiply to give you 6 times negative 10 is negative 60, and add to give you negative 7. So that would be factors, and again, one would have to be positive and one would have to be negative to give you a product that's negative. So negative 12 and 5 would work. That would give you negative 60, and add to give you negative 7. So if we break down the middle term, we get 6m squared minus 12m plus 5m. And again, it does not matter which order you put these middle terms when you're breaking it down, and you could put the 5m first if you want, and the negative 12m second. Just make sure that the negative is with the 12 and the positive is with the 5. You'll get the same factors if you do it the opposite way I did it, but they'll just be in a different order. So then you group and GCF. So this would have a GCF of 6. First group would have GCF of 6m, and then you'd have m minus 2 inside. And the second group would have a 5 and m minus 2 inside. And then your final factors, when you look at them, would be m minus 2 is the GCF, the binomial that's a GCF of both those groups, and left inside would be 6m plus 5. That's a positive 6m. Okay, the next one, you're looking for two numbers. And again, you should always check first to see if there's a GCF. Like, there is no GCF between these three terms, but always check, because it'll make your factoring a lot easier if you check for GCF first. So you're looking for two numbers that multiply to give you negative 40 and add to give you negative 18, which would be, again, positive and a negative. So factors of 40, 1 and 40 aren't going to work. 2 and 20 will, if you have the 2 as a positive and the 20 as a negative. So 2 and negative 20. So then you would break down that middle term. So you have 8p squared plus 2p minus 20p minus 5. I'm just going to move that up a little bit. And then group and GCF. So the first group, there's a 2 and a p that's a common factor of both of those terms, and you'll be left with 4p plus 1. Anytime you're taking the whole thing out, make sure you replace it with a 1, because 2p divided by 2p is 1. And then the negative should come out if the second term starts with a negative, and 5 would be the common factor, and this would leave you with a positive 4p and a positive 1. And again, you have this exact same thing in the binomial factor there, and that would be a GCF factor, so you can take that out. That would be the GCF of both of those groups, so you take that out and you're left with 2p minus 5. The next one, there is no GCF between the three terms, so we go ahead and start with our product of 20, 5 times 4, and our sum of 12. So two numbers that multiply, that would be 10 and 2. So we break down the middle term, got 5a squared plus 10a plus 2a plus 4. And then we group the first two, group the last two. So we take a 5a outside of a plus 2. 5a would be the GCF, and this one you would have 2 would be a GCF. So 2 outside of a plus 2 as well. And then you pull that a plus 2 factor out, and you'd be left with a 5a plus 2, and those would be your factors of your given trinomial. The next one, E, doesn't have any common factors either to start, so we know 3, looking for two numbers that multiply to give you 3 times 8, which is 24, and add to give you that middle coefficient, which is negative 10. So if they multiply to give you positive but add to give you negative, they must both be negative. So that would be negative 6 and negative 4 would multiply to give you a positive 24 and add to give you a negative 10. So if you break down the middle term, we've got 3w squared minus 6w minus 4w plus the 8. And then group. And in the first group, 3w is your GCF outside of w minus 2. And then the second one, even though both terms aren't negative, if there's a negative starting off, you take that out. So out of 4w and 8, the greatest common factor of 4w and 8 is 4. And then if you take it out of the first term, you've got just a w left. And if you divide the second term by negative 4, you've got minus 2 left, sorry. So now you've got a w minus 2 that you can pull out of both of those groups, and you're left with 3w minus 4. Okay, so the next one, again, just a quick check, there's no GCF between all three terms, so you're looking for two numbers that multiply to give you negative 36, and add to give you positive 9. So that would be, again, one of the factors would have to be a negative, and I'm thinking that would be a 12 and negative 3. So if you break down the middle term, that would give you 4c squared plus 12c minus 3c. We'll add to give you the positive 9c. And then you still got the minus 9. Then group. And the GCF of the first terms would be 4c outside of c plus 3. And take out that negative, and you're left with c plus 3. And then c plus 3 would come out outside of 4c minus 3. And you should always do a quick check when I haven't been putting it in here because I don't have a whole lot of room. But you should just do a quick check in your head to make sure that when you multiply those out, you will get what you started with back again. So c times 4c is 4c squared minus 3c plus 12c will give you the positive 9c. And then 3 times negative 3 will give you the negative 9. Okay, so the next one now, there is a GCF between all three terms, so that should be factored out first. So I've got 2 outside of, because 2 is the GCF, 2 outside of t squared plus 2t minus 24. And think of, now you're going to try to factor the inside trinomial there. So you're looking for two numbers that multiply to give you negative 24 and add to give you positive 2. Now you don't have to show this little work here that I'm putting on the side if you can do it in your head, but I'm just writing it there to let people know what we're looking for. So two numbers that multiply to give you negative 24 and add to give you positive 2 would be a positive and a negative factor of 24, and that would be 6 and negative 4. 6 and negative 4. So when it's an easy trinomial, what I mean by an easy trinomial, you don't, like the leading coefficient is 1 for the squared term, you can go right into your factors for that. You don't have to do decomposition. So we know from our earlier work in the chapter that this would just be t plus 6 and t minus 4. And the next one, there's a 3 that can come out first. So the 3 comes out and you're left with p squared minus 6p plus 8. And again, what's inside is an easier trinomial. It has a leading coefficient of 1 in front of the p squared. So you are looking for two numbers which multiply to give you the 8 and add to give you the negative 6. And that would be, if they multiply to give you positive but add to give you negative, they must both be negative. So that would be negative 4 and negative 2. And again, that's an easy trinomial. It's not one that you have to use decomposition on. So you can just go straight to your factors. P times p will give you the p squared. Minus 4 times minus and a minus 2 would give you the last term of a positive 8. And then when you add the inside and outside, you will get the negative 6. And then, of course, that 3 is still outside to multiply through to get what you started with. All right, the next one does have a GCF as well, but it's not the leading coefficient is not the GCF. It's only a factor of the leading coefficient. So in this case here, we've got 2 is the only thing that's a GCF of those three terms. So we do take it out because it does make the numbers a little smaller to work with. So 2 outside of 3a squared minus 4a minus 7. So again, if we look at what's inside, we are looking for two numbers which multiply to give you a negative 21 and add to give you a negative 4, which would be negative 7 and 3. So if we break down the middle term, we've got 3a squared minus 7a plus 3a minus 7. And then if we group the first two and group the last two, we have, I'm just going to put square brackets here now because we're going to break this up a little bit inside. We're going to have an a outside of 3a minus 7. And 3a minus 7 doesn't have anything in common, so we just have a 1 outside of 3a minus 7. There's nothing in common, take out a 1. I'm just using those square brackets to separate, because I've got a 2 outside there that needs to be multiplied by the entire thing. So then we've got 2 outside of, if you factor this group and this group, look at what's common, there's a 3a minus 7 outside of the a plus 1. And I don't really need those square brackets anymore now, so I can get rid of those. And then my factors would be 2 times 3a minus 7 times a plus 1. You got to have that 2 in there, or else you're not going to get the 6a squared minus the 8a minus the 14 back. So I can probably move that 2 a little closer. All right, so the next one, if you look at the 3 terms, there is a 4. That's a GCF of all 3 of those terms. So that would be 5y squared minus 4y minus 1. And then you'd be factoring this part in here. So you'd be looking for the two numbers that multiply. If it is factorable, are there two numbers that multiply to give you negative 5 and add to give you negative 4? And that would be negative 5 and 1. So this would become 4, and then we'd have 5y squared. We're going to break it down using minus 5y plus 1y minus 1. And then we're going to group in GCF. So that'd be 5y outside of y minus 1 plus the second group only has a 1 as a GCF. And I'm using round brackets, but those could be square if you'd rather change them to square brackets, those outside ones, to make it more definitive, you can. So now what we have left inside, if we factor that, is y minus 1 outside of 5y plus 1. And again, I can just drop those brackets now. I don't need those outside brackets anymore, because it is in a product form again. And I can move that 4 a little closer. And those are my factors. Okay, if we look at 24, 20, and 24, they all have a factor of 4, I think is the biggest one. So 4 outside of 6h squared minus 5h minus 6. And then you'd be looking for two numbers that multiply to give you 6 times negative 6 is negative 36. And add to give you negative 5. And that would be negative 9 and 4. So this would be 4 outside of 6h squared minus 9h plus 4h minus 6. And then you group, and that would be the common factor of 6h squared and 9h would be 3h outside of 2h plus, no, minus, sorry, 2h minus 3, and 4h and 6 would only have a 2 as a common factor, and that would be a 2h minus 3 left inside again. So you know you're on the right track for factoring. If you've come up with those numbers, there should be factors. So these two factors, again, should be the same that's left inside. If they're not, you've done something wrong. So if we look at this now, again, we got 4 outside of, so we've got 2h minus 3 outside of 3h plus 2. And again, I don't need that extra bracket anymore. So there's my factors. And the next one here, sorry, I can see that an x is common to all three and a 2. So we'd have a 2x outside of 2x squared minus 5x minus 12. And we'd be looking for two numbers which multiply to give you negative 24 and add to give you negative 5. And that would be negative 8 and 3. So if we break down the middle term using those two numbers, we've got 2x squared minus 8x plus 3x minus 12. And then that's going to give you, should be using my equal signs there. And that one there as well, I guess. Okay, so then we have group. So we go back 2x outside of x minus 4, plus the next group, 3 is a common factor outside of x minus 4. And then we would have 2x outside of x minus 4 by 2x plus 3. And again, I don't need that extra bracket there anymore. So 2x outside of x minus 4 by 2x plus 3. All right, and there's a couple more there to try. So the next one, it has a star next to it, and the reason it has a star next to it is because there's an extra variable in there. So these ones here, you can just kind of do them the same way. If you kind of ignore that n and n squared, it is just one of those trinomials that we were factoring earlier in the chapter, and we'd be looking for two numbers that multiply to give you negative 10 and add to give you negative 3, which would be negative 5 and 2. So if we break this down, we would have, we don't need to break it down, sorry, we can go right to the factors because that has a leading coefficient of 1. So we can go right to our factors for that one, and it would be, we'd need an m and an m, and we need a minus 5, and we need a plus 2, but we would need to have an n with those, so that we get the n squared for the last term, and an mn when we do the inside and the outside. So it's basically the same thing, except now you've got to include an extra variable. And the last one here is similar to m as well. And basically, you would be, if you kind of just look at that pattern, it's the same. You got an x squared term, and at the end you got a y squared term, and in the middle you got a combination xy term. So it has the same pattern as the one we just did in m. So we're looking for two numbers. We'd be looking for two numbers which multiply to give you the 12, and have to add to give you the negative 8. So if you think of the factors of 12 that multiply to give you a positive and add to give you a negative, it would be negative 6 and negative 2. Would multiply to give you a positive 12 and add to give you a negative 8. And because this has a leading coefficient of 1, we can go right to our factors. And we can put in x, and we can put in the y and the y to give you the y squared term. But then we would have minus 6 in one and minus 2y in the other. So, and you could check if you want to see if they would expand when you multiply those two binomials. Would they expand to give you x squared minus 8xy plus 12y squared? And they would. Okay, so there are some questions here on pages 177 and 178 that are in your textbook that you can try for extra practice on this material.